In this lesson, we're going to learn about what we mean by a horizontal stretch or a horizontal compression. Now, before we start looking at this, let's remind ourselves about the previous lesson when we talked about a vertical stretch or a vertical compression. And so remember, when we deal with a vertical stretch or vertical compression, remember this is our parent function, right? So y equals absolute value of x, and notice that this right here is y equals 3 absolute value of x, and this is y equals 1/3 absolute value of x. So when we deal with a vertical stretch or compression, that's where you have that number on the outside of your parent function. So if you're taking your parent function and you're multiplying it by some number, like this, 3 or 1/3, then you're dealing with a vertical stretch or a vertical compression. Now, just keep in mind, though, that number on the outside could be negative, right? So be a little bit careful with your statements, because if it's negative, then that also is a reflection about the x-axis. So don't forget about that. Okay, so let's remind ourselves about what made this a vertical stretch or a vertical compression. So if you have your parent function here, so if you look at this parent function, so here's a point on my parent function. And I'm going to take this point and I'm going vertically up to this point here, right? So I went from here to here. So that's the idea, that vertical. And then I went from here to here, so vertical. I took this point of my parent function and I went up like this. So that's a vertical. So that's vertical. Same thing, I could go down, that is vertical. This is vertical, this is vertical. So we know what we mean by the idea of that vertical. All right, so whenever you have a number on the outside, whenever you're multiplying your parent function by a number on the outside, that's a vertical, either vertical stretch or a vertical compression. I want you to notice something though. So remember this, and that's going to help us when we talk about this horizontal stretch compression in a little while. A horizontal stretch or a horizontal compression is a lot easier to understand than it is for a horizontal stretch or a horizontal compression. This is easiest to understand. So that's usually why it's always done before the discussion of horizontal stretch or horizontal compression. But what you notice is that to use transformations to graph this, we took the y value. Remember, this is my y value, right? Y equals absolute value of x. So there's my y value. So we took this y value and we multiplied by 3. So if you look at your parent function, this y value is 1. 1 times 3 is 3. Over here, if you look at this point, this y value is 2. 2 times 3 is 6. See that? And then over here, this y value is 3. 3 times 3 is 9. So notice that the x coordinates stayed the same. So notice x stayed the same, right? X stayed the same. It is the y coordinate. It is the y coordinate that changed. All right. So to use transformations to graph this, I take the y coordinate from my parent function and multiply by 3. All right. Now, and then the same thing here. So I take the y coordinate from my parent function and multiply by 1/3. So notice 1 times a third is 1/3. 2 times a third is 2/3. You see, this is 2/3 right here. The y value here is 2/3. This is easier to see because 3 times a third is 1, so there's that 1 here. Okay, and so you get this vertical conception here. Okay, now remember, so the stretch compression. All right, so you're think of this as a rubber band, and so you can take this part of the rubber band right here, and you're pulling it up, right? So it's kind of like you're stretching it. So you're stretching that rubber band. So your foot is on this part here, and you're stretching it. Though this right here would be considered a vertical stretch. Okay, so that's a vertical stretch. I'm gonna put the word vertical stretch here. All right, and then we'd say by a factor of 3 in this case, because that's what this was. Okay, then to think about compression, think about pressing on something, compressing. So the word press right here. So you're pressing on something. So here I'm taking this absolute value of x. So let's say this rubber band, and I'm pushing down on it. So that's a compression. So this would be a compression. So this would be a vertical compression. Vertical compression. by a factor of 1/3, because you see 1/3 here. Okay. All right. Now, one other thing I got to remind you is this. So remember we said that if you see a negative here, though, remember that obviously that would not be the graph. If that was a negative, the graph would be down here. It's a reflection about the x-axis. But what I need to remember is this. So if the absolute value of k, so, and I'm using absolute value here of k because if k is negative, obviously if this is -3, then -3 is not greater than 1. So that's why I'm using absolute value of k. So whatever k is, take the absolute value of it first. If it's greater than 1, then you have a vertical stretch. Okay? If the absolute value of k is between 1 and 0, so let's say proper fraction, then you have a vertical compression. Okay, vertical compression. All right, now let's look at horizontal stretch or compression. All right, so it's a little bit, this right here is a little bit harder to understand with regards to the idea of stretch compression. But the horizontal is easy. It's a stretch compression that's kind of different than this one. This one is a little bit easier to see what we mean, why this would be a stretch and this would be a compression. This probably will not be for some of you, but we'll deal with that. All right, so let's look at horizontal stretch, horizontal compression. All right, so now we're going to talk about a horizontal stretch or horizontal compression. Now, I want you to notice, see where if you look at your parent function, absolute value of x, notice this time our number is inside the parent function. So you're multiplying x by 2. Here you're multiplying x by a half. Okay? In the previous one, it was on the outside. See that? Okay, so it's on the outside, it's a vertical stretch or compression. If it's on the inside, it would be horizontal. Okay, so let's see why this is a horizontal. So here's my parent function, and I want you to look at this point right here. To get to that point, to go from here to this graph here, I went horizontally. See that? So horizontally, horizontally, horizontally. Okay, so notice the y coordinates stay the same. It was the x coordinate that changed. Obviously, the x coordinate had to change because this x has a coefficient of 2. This x has a coefficient of 1/2. So you're changing your x values. Okay, the y value would stay the same. All right. So notice I'm horizontally going to the left here, and then the same thing here to go from the parent function to this orange graph, which is y equals the absolute value of 1/2 x. I went to the right. See this? Just like this. All right. Now, so that's horizontal. So we know that we're dealing with a horizontal here. If the number's on the inside, we're dealing with a horizontal stretch or a shrink. So I'm going to write this right here. So y equals f of kx. This is a horizontal transformation. So it's either a stretch or it's a shrink. So we would say this one of these would be a horizontal stretch and the other would be a horizontal compression. All right, now let's talk about stretch and compression here. So listen very carefully. Think of this as a rubber band, okay? Think of this as a rubber band. So you're taking this, let's say this right here of the rubber band, all right? This right here. Let me go ahead. I should use 2 pencils so I can erase. So I'm taking these 2 points on the parent function right here, all right? And if this was a rubber band, I'm pulling it, right? So I'm stretching that rubber band. See that? That's a stretch. So when you go horizontally, this is a stretch. Think of this as a rubber band, and you're stretching it. You're stretching that rubber band, okay? So this would be a stretch right here. So that's a stretch. So this would be a horizontal stretch, okay? Now, to get to the blue graph, you got to think this now, all right? So think of this as your, I'm trying to see how I'm going to do this. Let me do it this way. So think of this as your rubber band, right? Your parent function, and you're not going to stretch it because stretching does this, correct? That's stretching. So what you're going to do is kind of like you're compressing that rubber band. So you're taking that rubber band right here, the absolute value of x, the parent function, and you're compressing it. So you're pressing on it. So this is pressing. So compression, the word press, compression. Okay, so this is stretching. This would be compression. All right, it's compressing. So you're pressing on the absolute value of x. So you're pressing on that rubber band, let's say. All right, so this right here would be a horizontal compression. All right, so horizontal stretch, horizontal compression. All right, so that takes us to this now. So when looking at K, how is looking at K going to tell me right away if we're dealing with a horizontal compression or a horizontal stretch? All right, so that's what we need to look at. Okay, so notice that 1/2. When we looked at 1/2, remember 1/2 is a proper fraction, right? A proper fraction. So in looking at 1/2, we dealt with a horizontal stretch. When we looked at 2, which was an improper fraction, so remember an improper fraction is a number greater than 1. So when we looked at 2, that was a horizontal um, compression. All right, so let's write it this way. All right, so listen carefully to this. All right, so listen carefully. All right, so let's go right here. So y equals f of k of x, we know will be a horizontal stretch or a horizontal compression. Okay, we know that now. Okay. All right, so it'll be a horizontal stretch or a horizontal compression. All right, so we know that, we also know that if k is an improper fraction, all right, a number greater than 1, if k is a improper fraction, then we have a horizontal compression. All right, so if k, now let me say something here, and I'm going to rewrite it in a different way. So remember, k could be negative, right? So if this is negative, remember that's a reflection about the y-axis. So if it's negative here, then that will be a reflection about the x-axis. So if k is negative here in that form, that's a reflection about the x-axis. And another lesson you learned that if k is negative here, then that would be a reflection about the y-axis. So I want to do this because k could be negative, and I want you to think that for example, this is -2. So I don't want to say this. I want to say if k is greater than 1, because some of you are going to say, well, that is -2. -2 is not greater than 1, right? But its absolute value is. So if the absolute value of k is greater than 1, then we have a a horizontal compression. Okay? If the absolute value of k, let me do it this way. If the absolute value of k is between 0 and 1, okay, if the absolute value of k is between 0 and 1, then we have a horizontal stretch. And really, the absolute value of k is never negative, right? So really, I could just say if the absolute value of k is less than 1, because the absolute value is never negative. So if the absolute value of k is less than 1, then we have a horizontal stretch. All right? Okay, now let's look at this. It was very easy. It was very easy when we talked about a vertical stretch to see that to get the graph of this, I take the y value and I multiply by 3. Okay, that's easy to see. I take the y value and I multiply by a third. It's easy to see, right? Okay, that is not the case here. So don't think that this says this. Be careful. This does not mean take the x value from your parent function multiplied by 2. That's not what this is. Okay? Because look. So 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 I went from here to here, right? So here's the absolute value of 2x, and here's the absolute value of x. So if you take this right here, which has x coordinate 4, remember your y values are the same, your x coordinates are different, which has x coordinate 4, 4 times 2 is not 2, right? So be careful. You don't take the x coordinate multiplied by 2. You actually divide by 2. So look, when I went from x equal 4 to x equal 2, that's a division by 2. All right. So if I take, let's say, x equal 3 here, divide by 2, 3 divided by 2 is 1.5. If I take, let's say, this x coordinate, which is 6 here, right here, divide by 2, I get, let's see what's here. So I get this x coordinate to be 3. Okay, so, and the same thing here, if you look at this one, so when you're dealing with a horizontal, stretch or compression, you don't take x and multiply by half, because look what happens. When x is this point here, x was what, 3, right? 3 times 2 gives us 6. Over here, my x coordinate is 4. 4 times 2 gives me this x coordinate, which is 8. So intuitively, it's just the opposite of what you would think. All right, so here's what I need for you to remember now, and that's this. All right, so if you have y equals k times x, so notice you're multiplying x by k here. So that would be a horizontal stretch or a horizontal compression. So if the absolute value of k is greater than 1, then the graph is compressed by a factor of, okay, so remember what we did to get this graph here. We took the x coordinate here, right here, and we divided by 2. So notice this x coordinate here is 4. 4 divided by 2 is 2. So I went from here to here. Okay? So you can divide by k. So is compressed by a factor of, and so dividing by k means the same thing as multiplying by 1 over k. All right, so then the graph is compressed by a factor of 1 over k. If the absolute value of x is less than 1, I'm sorry, not x, k, that should be k, I apologize. If the absolute value of k is greater than 1, then the graph is compressed by a factor of 1 over k. If the absolute value of k is less than 1, then the graph is stretched by a factor of 1 over k. All right? Okay, so I know that this is a little confusing with regards to horizontal stretch or horizontal compression, but let's look at some examples, and I think that may help a little. Okay, so we all know that when graphing the parent function absolute value of x, these are the points we'll use. 1, 1, negative 1, 1. Makes sense, right? Because when x is 1, the absolute value of 1 is 1. When x is negative 1, the absolute value of negative 1 is 1. When x is 0, the absolute value of 0 is 0. And then when x is 2 or negative 2, the absolute value of those is also 2, right? Okay, and so that's how we graph this function right here, the absolute value. But when I look at y equals 2x, for example, when I look at y equal 2x, so remember, when we're looking at these, my y coordinates stay the same. My y coordinates are going to be the same because this is a horizontal transformation. So horizontally a stretch or a compression. So your y values stay the same. So what I'm going to do now is I'm going to keep all these y values the same right here. Okay? Keep all those the same. And so what this tells me to do is it says, so when you see the absolute value of 2x, so that tells me that I'm going to take the x coordinate here. I'm going to show you right real quick. Take the x coordinate and I'm going to divide by k, 1 over k, excuse me. The x coordinate here. Let me do this. Okay, let me write it like this. Okay, so to get this x coordinate here, I'm going to take this right here because that's where the y values are the same. So x is 1. So that says I take the x coordinate here, and I'm going to divide, or I'm going to, multiply by 1 over k. So times, so remember this one comes from here. So times 1 over k, and that is k here is 2. All right. So 1 times a half is 1/2. So that's what we're going to put here. For this one here, I'm going to take x is going to equal -1 times 1 over k, which is 2, which becomes -1/2. So this point here is -1/2. Over here, 0, that's going to stay the same, 0. Okay, now let's do 2. When x is 2, I'm going to multiply that. See, x is 2 here, right? So when x is 2, I'm going to multiply that by 1 over k, and k is 2, so 2 times a half is 1. And the same thing here, that's going to be a -1. And I want you to notice that all of these right here corresponds to what you see here. So watch. Remember right here. So 1/2, see x is 1/2, y is 1. See it right here? X is 1/2, y is 1. X is -1/2, y is 1. Okay, let's go to 0, 0. That's the origin. When x is 1, y is 2. See that point here? 1, 2. And then when x is -1, y is 2. Right here. Oops, sorry. Right here. Okay? So that's this right here. So notice to get this graph, you don't multiply x by 2. You take each of those x coordinates here and you multiply by 1 over 2. Okay? You multiply by 1 over 2. And then we look at the other one, just real quick, y equals the absolute value of 1/2 x, the same thing. So I want all these y values to be the same. And just real quick, let me just kind of show you this. So I'm going to take this x coordinate, so x is 1. So to get this x coordinate, I'm going to take this one here, which is 1, and I'm going to multiply by 1 divided by k. K this time is 1/2. All right, but you got to remember when you are dividing fractions, you're going to change the multiplication problem. So this becomes 1 times the reciprocal of 1/2. So this is 1 times, and then 1. Let me go ahead and do this here. So this part here will be 1 divided by 1/2. Remember, it's 1 times the reciprocal of 1/2, which is 2. So that's 2. So this right here is 2. This right here. You saw that here, right? So 1 divided by 1/2 means 1 times the reciprocal of 1/2, which is 2. So 1 divided by 1/2 is 2. 1 times 2 is 2. And then this right here, when x is -1, then that will be a -2. This is 0. Now let's look at 2. So for this one, I'm going to take 2 when x is 2, and I'm going to multiply by 1 divided by k. K, remember, is 1/2. But remember, 1 divided by 1/2 means 2, right? So this becomes 2 times 2, which is 4. That's 4. So 4 and then -4. And so notice what happens. So let's look at this now. So in my orange graph, I have 2, 1. You see that? Then I have -2, 1 right here. Then I have 0, 0, the origin. Then I have 4, 2, which is here. And then -4, 2. All right, so we're dealing with the horizontal. You actually can take each of those x coordinates right here from your parent function, and to get this one, you're going to get both of them, you're just going to multiply each of those by 1 divided by k. All right, so always multiply by 1 divided by k. Multiply the x coordinate. When you're doing vertical, you multiply the y coordinates by k. When you're doing horizontal, you multiply the x coordinates by 1 over k. All right? So, remember what I just said. For vertical, stretch, compression, multiply the y coordinates by k. For horizontal, stretch, compression, multiply the x coordinates by 1 divided by k. All right, so the difference between the two. For vertical, you're going to multiply the y coordinates by k. For horizontal, you multiply the x coordinates by 1 divided by k. All right? Okay, now let's look at a couple examples. All right, so let's say we have this function here, and let's assume that this is our function y equal f of x. All right, and let's say we want to graph the function y equals f of, let's say, 3x. That'll be fine, 3x. All right, so let's say we want to graph the function y equals 3x. Okay, so remember that's a horizontal transformation, right? Either horizontal stretch or a horizontal compression. Okay, but we know that since k is greater than 1, k in this case is 3, and 3 is greater than 1, then we know that this is going to be a horizontal, because we're going to move it inward like this. So that's going to be like this. So we'll be moving this way. So that's going to be a horizontal compression. Okay, horizontal compression. All right. So remember what we do. So if we look at, let's do this point first right here. So this point has coordinates 2, 9. Okay, so 2, 9. And so this says I take my x coordinate, which is 2, and I divide and I multiply by 1 over k. So notice, I'm going to do it this way. So when x is 2, I'm going to take 2 and I'm going to multiply by 1 over 3, which is 2/3. So my x coordinate would become 2/3. So when x is 2/3, my y value stays 9. So I'm just moving it this way. So instead of x being 2, my x coordinate is going to be 2/3, which is about here. Okay. Knows that 0, 0 stays 0, 0, so I didn't do anything with that. Now let's get this point here. This point here is 5, 9. Let's do the same thing. So when x is 5, I'm going to take 5 and multiply by 1 divided by k. So which in this case is 1/3. So I get 5/3, which is 2 1/3. So when y is 9, my y value for this will be, I'm sorry, my x value for this will be 2.5. Oops, not 2.5, 2 1/3, excuse me, 2 1/3. So 2 1/3 is about here, okay? And then over here, that's the point 90, right? 90. So when x is 9, I'm going to say 9 times 1/3, which is 3. So I get this point right here. All right. And so now the blue graph is going to be the graph of this function here. So I'm going to go ahead and do this just to show you. So all you're doing is taking each of those x coordinates, and you multiply by 1 divided by k. The y coordinate stays the same. All right. And then we get this. So this right here would be, let's see, 9 times 1/3 is 3. Okay, so this right here would be, this one right here, you can't see it very well. Oops, I did the wrong, did I do the wrong one? Okay, 5 times 1/3 is 5/3, which is, oops, I did that wrong, sorry. That's not 2 1/3, that's 1 2/3. So I messed that up. So let me go ahead and erase. Okay, so I went ahead and erased all this right here. I did go ahead and erase. Now remember, I made a mistake here. 5 times a third is 5/3, which is 1 and 2/3. I'm not sure why I said 2 and 1/3, but 1 and 2/3. So my x coordinate, so when for this function here, f of x equals 3x, when this point here, I think it was, I'm messing up with all my points. No, right here. So for 5, 9, when x was 5, 9, for this function here becomes 1 and 2/3, 9. So 1 and 2/3, 9 is, let's see, 1 and 2/3 is about, 1 and 2/3 is about here. Okay? All right. And so now we're just going to do this. So that's where the new point is. So this point went from here to here. So remember, I went this way. So it's a horizontal compression, horizontal compression. And so you get this. All right, so this right here, the blue graph, is the transformation of f of x. So this blue graph here is f of 3x. All right, so remember, a horizontal compression, you're taking each of those points and you're compressing it by a factor of 1/3. Okay, factor of 1/3. So you're doing a horizontal compression. Okay, same thing here. You're taking this part here, compressing it. All right, so this part of the graph became this part, and this part of the graph became this part. All right, so this right here would be the graph of f of 3x. All right, so let's go ahead and look at one more. All right, so let's suppose we had this, and you want to graph y equals, let's say, f of 1/2 x. So f of 1/2 x. So remember what that, to go from here to here. So to graph this, you're going to take this function here, okay, and you're going to do a horizontal stretch. All right, so if the absolute value of k, so k is 1/2, the absolute value of 1/2 is 1/2, is less than 1, then that's going to be a horizontal stretch. So you're going to take each of those parts and you're going to move it to the right. Okay. All right. The best way to do that is to look at those coordinates. All right. So because these are all segments. So let's look at this segment right here. So this point is 2, 9. All right. So remember, this says I take my x coordinate right here, and I'm going to multiply by 1 over k. All right. So for x equal 2, I get 2 times 1 divided by half. But remember, 1 divided by half is 2. And so this becomes 2 times 2, which is 4. So my new point, instead of 2, 9, that point becomes 4, 9. So 4, 9 is right here. Okay? And 0, 0 stays 0, 0 for this reason. So I just want to remind you why 0, 0 stays 0, 0. Because for x equals 0, I get 0 times 1 divided by 1/2. So remember, you always multiply the x coordinate. See this right here? That's 0, 0. So always multiply the x coordinate by 1 divided by k. So 1 divided by 1/2. Well, 1 divided by 1/2 is 2. And then 0 times 2 is 0. So it stays that. So now this part of the graph becomes this. All right, so let me show you. So that part becomes this. All right. So I want you to notice I went from this piece, and I went horizontally to the right. Okay, horizontally to the right. Let me make sure I did this correct. So the point 29 became the point 49. 29. Let me make sure. Oops. Okay. So it looks like this point was not 29. What was that point? It's like I'm messing up on this right here. So that was the point um, 3, 9. I apologize again. This is 3, 9. So 3, 9. So that should be 3 right here. So when x is 3, I get 3 times 2. 3 times 2. It's pretty easy sometimes to make these mistakes, so but be very careful. So 3, 9 becomes 3, 6. I'm going to have to erase that blue line again to make sure it works. 3, 6. All right, let's do this one more time, guys. So when x is 3, see that was 3, 9. I said 2, 9. That was 3, 9 right here. 3 right here, 3, 9. It's hard to see these numbers down here, but that's 3, 9. So 3, 9, when x is 3, my y value, my new y value becomes 6. So here's 6, 9. Make sure I'm doing this. So that's 4, 5, 6, and then 6, 9. All right, so that becomes this now. All right, so it makes a little bit better sense. I knew something was wrong because when I'm did the horizontal, the size didn't quite make sense. All right, so let's go ahead and graph this right here. All right, and so notice going from here to here, from here to here. So whatever this x coordinate is, I doubled it, it gets this x coordinate. Whatever this x coordinate is, I doubled it, it becomes this x coordinate. Whatever this x coordinate is, obviously this one's easy to see, that is 2. 2 times 2 is 4. See that? Okay, so that's a horizontal stretch. All right, now let's do this point here. Okay, so that point is the point. Make sure this is correct this time. That is 7, 9. So let's talk about what happens with 7, 9. So for x equals 7, I get 7 times 1 divided by k. Remember, k is 1/2. And then 1 divided by 1/2 is 2. That becomes 7 times 2, which is 14. So 7, 9 becomes 14. See, x is 7. So now I get the point 14, 9. All right, so plot the point 14, 9. So 14, 9 is, and I'm going to go ahead and do this because I know I did not make a mistake this time. So that is 14, 9 right here. So I'm going to connect this blue with this blue. So I get this. All right, so let's say I get this right here. All right, and then this point right here is 9, 0, right here. So when x is 9, so for x equal 9, I get 9 times 1 divided by k, which is, remember, k is 1/2. That's a half. And 1 divided by 1/2 is 2, so I get 9 times 2, which is 18. All right, 18, so this is 16, 17. Let's say 18 is right here. And so then I connect those. And so let's see, right here. All right, and so this blue right here, this blue is then this function, f of 1/2 x. So if the black right here, represented f of x, then the blue, this blue right here, would represent f of 1/2 x. Okay, and so notice it is a horizontal stretch. See this? I'm taking each of those x coordinates and I'm stretching it to the right. Okay, 9 times 2 is 18. All right. Okay, so that is, and I would go ahead and then erase. I would erase all those little arrows, so that way it uh, doesn't complicate the picture that it's supposed to look like. Okay, so this is it. So there is your graph. It's somewhat a little complicated than vertical stretch, vertical compression, but all and notice the little errors I made along the way. So like be careful with your coordinates, because if your coordinates are correct, then it's gonna not look right. And so that's why I knew when I drew this line that it didn't make any sense, because this had to be doubled and it wasn't doubled. Okay. All right, so that is the lesson, and I think you have enough to be able to work on the worksheet and the assignment on this part. So this is a lesson on vertical stretch. I'm sorry, horizontal stretch, horizontal compression. And remember with the horizontal stretch, horizontal compression, if whatever K is, and remember I'm using absolute value because K could be negative, and that, remember when you see a negative here, that's inside like this, that would be a reflection about the y-axis. So if K is negative, always remember you're looking at the absolute value. So the absolute value K is greater than 1, then the graph is compressed by a factor of 1 over K. If the absolute value of K is less than 1, then the graph is stretched by a factor of 1 over K. All right, so that is the lesson on horizontal stretch, horizontal compression.